All right, this is lesson 10.3.3, problem 10.133. So it says San Francisco is well known for its fog, very thick, low-lying clouds that hide its hills. On a foggy day, Penelope was practicing kicking a football on the football field of her school. Once she kicked the football so high that it disappeared into the fog. If the height h of the ball in feet could be represented at time t in seconds by the equation h equals negative 16t squared plus 96t, and if the fog was 140 feet off the ground, during what times of its flight was the ball not visible? Okay, so we're trying to figure out when does that ball go up there into the clouds, okay? So it says that the fog was 140 feet off the ground. So I'm going to take my equation, negative 16t squared plus 96t, and I'm going to make it an inequality. I know that I cannot see it when it is at 140 feet off the ground or above 140 feet. So I'm going to flip my screen here. Maybe. There we go. Okay, so I know that I cannot see it when this is greater than or equal to 140 feet. So I'm going to change my equation to that. All right, and then I'm going to need to figure out where, what are the roots? What are the x-intercepts, or in this case we have t. So I'm going to first get this in standard form. So I'm going to subtract 140 from both sides. Oops. All right, so once I have it like that, then I'm going to need to solve this. And so I can either use the quadratic formula, or I can factor and use a generic rectangle. These are pretty big numbers, so I could use the quadratic formula, but I know that they have a common factor. So I know that 4 goes into each of these terms, or negative 4 goes into them. So I am going to, I'm going to take out a negative 4. I'm going to divide out a negative 4. So then I'm left with 4t squared minus 24t plus 35, and that's greater than or equal to 0. And then I'm going to do a generic rectangle and diamond with what I have inside of the parentheses there. So I've got 4t squared and 35. When I multiply those together, I get 140t squared. And I have negative 24t in the bottom. So I'm thinking about those factors that multiply to give me 140t squared and add up to negative 24t. I know those are negative 10t and negative 14t. Put those into my generic rectangle. And then let's see how to figure out the dimensions of this generic rectangle. So I know that 2t goes into both 4t squared and negative 10t. So this is going to be 2t and 2t. And then 2t times negative 5 is going to give me those negative 10t's. 2t times negative 7 is going to give me those negative 14t's. So now written my factors. Remember, I have that 4, or that negative 4 that I factored out. And I'm going to set each of these equal to 0. So I have a negative 4 equal to 0, which is not true, so I can throw that out. I've got 2t minus 5 equal to 0. Solve that for t. So I get that t is 5 halves, or 5 divided by 2 gives me 2.5. And I'm going to put this, it's decimals, I'm talking about time, so 2.5 seconds is what that means there. And then I have 2t minus 7 equal to 0. I'm going to solve for t. So I get that t equals 7 divided by 2, or if I write that as a decimal, 3 All right, so remember what's happening in this situation. She is kicking a football, and at some point it goes into the clouds and we don't see it. And then at some point it comes back down, and then we see it again. So these are our boundary points, okay? So this is what's happening here. She is not seeing the football between 2.5 and 3.5 seconds. So remember we had the, let me go back to my original problem. It was the greater than or equal to sign. So we lose sight of the ball when we are at 2.5 seconds or more, and we don't see it when it is less than or equal to 3.5 seconds. Okay, so the ball cannot be seen between 2.5 seconds and 3.5 seconds.